Okay, guys, welcome to day 5. It's our last day. We've got one last thing to cover, which is reflections, horizontal and vertical reflections of exponential functions, and then we're done. So, moving on, there are, remember our high-vo rules, they apply here as well. So, on the inside of the function, that's high, that's h, that's horizontal. So, this means horizontal. Now, when we were doing transformations, I had a lot of kids just say horizontal, and that's actually incorrect. You have to say horizontal reflection. This would also be a horizontal reflection on the inside. If it's on the outside in front, that is a vertical reflection. So it flips down. And this one is also vertical. That's really the only new thing that we're doing today, and then we're going to combine it with all of our other transformations. Okay, so we've got 3 to the x. We're going to start there. So every time we have a function, I do -1, 0, and 1 here. And then I just graph the parent, or I just do the table with the parent function on the right. So this would be 1/3, 1, and 3. Okay, and then I graph those. -1, 1/3, 0, 1, and 3. Then I deal with the transformations. This is on the inside, so it's a horizontal reflection, which means that everything that's on this side is going to go over here, and everything that's on the left side is going to go over there. They're going to flip over that y-axis. Okay, so I'm going to use a different color, and I'm going to show that +1 is going to come over here to -1. And 0, 0 is going to stay put, and negative, that y value, or the x value, -1 is going to come over here to +1. So growth is actually going to end up looking like decay. Now, things that you need to know, you need to have one long curve with arrows on both sides, and you have to show, even if it's on the x-axis, a dashed long line for a horizontal asymptote, and then write the equation, which is y equals a number. In this case, it's y equals 0. That is the only new thing that we're doing today. We're adding reflections onto our exponential functions, and then more transformations to come. Okay, so this next one is 2 to the x. So again, same process. -1, 0, 1, 1/2, 1, and 2. Okay, and then I graph that. -1, 1/2, 1, and 2. Now, you can connect these if you want to, but I'm just going to go ahead and do the transformation. So I'm going to grab the blue, and we're going to transform. This is a vertical reflection. So everything that's above is going to reflect down below. So +2 becomes -2, and +1 becomes -1, and +1/2 becomes -1/2. We reflect everything down. Now I'm going to connect these points. One long curve, arrows on both sides, and we've got our nice horizontal asymptote. Again, that's at 0 because it hasn't moved up or down. Okay, here's a decay. So we've got a -1, 0, 1, always the same. And then we'll do 1/4 to the x. 1/4 to the -1 is 4, 1, and 1/4. And then I graph that. I've got -1/4, 0, 1, and 1/1/4. Then I look at my transformation. This looks like it's a horizontal transformation, horizontal reflection, sorry. So I'm going to grab the red, and this -1 that's located here, this x value, this -1 is going to reflect over to +1, and 0, 0 stays put, and the +1 comes over to -1. I'm going to connect all those red dots, long curve, arrows on both sides, a horizontal dashed asymptote, and an equation, y equals 0. Okay, I think we're good. This is graphing decay with a vertical reflection. Okay, so we're going to put it all together. Start with finding the parent function. The parent function is 2 to the x. Same 3 points on the left. Then we do 2 to the -1, which is half, 2 to the 0, which is 1, and 2 to the first, which is 2. And you graph those points. So we've got this guy, and this guy. Okay, now we've got 2 transformations. I'll do them in green. I see a vertical reflect that has to be done first, always first. Transformations that involve reflections always have to be done first. And then this is on the inside. This is going to go left 7. Okay, so we're going to vertically reflect, which means we take everything up top and we move it down. So Positive 1/2 is negative 1/2. Positive 1 is 1. And positive 2 is now negative 2. And then we're going to pick all these points up and move it left 7. You have notability. I don't. We'll put that one there. This one here, and this one here. We didn't have any up or down movement, so it looks like I'm going to clean up my work a little bit. It looks like I'm going to have a horizontal asymptote here because we didn't move up or down. And again, I connect these with a nice long curve, getting close to that asymptote without crossing. My horizontal asymptote is at, again, y equals 0. That will not change until we have a vertical shift going up or down. Okay, let's try it again. Start with extracting your parent function, 3 to the x. So negative 1, 0, 1. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. And then I graph negative 1, 1/3, 0, 1, 1, 3. Okay, then I look at my transformations. I've got a horizontal transformation, horizontal reflection, and it looks like, ooh, my asymptote's going to change this time because we're going down 4. Okay, so I'm going to horizontally reflect, which means everything that's over here is going to go, so positive 1 is going to go to negative 1. 0, 0 stays the same. And then my negative 1 becomes positive 1. There's my horizontal reflection. And then I'm going to take those 3 green dots and move them down 4 along with my horizontal asymptote. I'm actually going to do that first. Horizontal asymptote is now down 4. And all of these points are now down 4. Oops. That should be a little closer. There we go. And there's our final product. And I'll go back and kind of clean this up a bit. And there we go. I need to say that my horizontal asymptote is now at y equals negative 4. It always will match whatever this number is. That's what your horizontal asymptote is going to be. Okay, moving on. So I see 1, 2, 3 transformations on this one. This would be an R3. It doesn't get any harder than this. I start my function not in a highlighter. Let's try that again. Negative 1, 0, and 1. And then y equals 1/3 to the x. So y to the 1/3, 1/3 to the negative 1, sorry, is 3. 1/3 to the 0 is 1. 1/3 to the first is 1/3. So I'm going to graph negative 1, 3, 0, 1, 1, 1/3. And leave those points there. And then I'm going to look at all my transformations. I have a vertical reflect. I have a right 2. And I have an up 4. I'm going to go ahead and say if it's going up 4, that means that my horizontal asymptote is at 4. And you could also go ahead and 1, 2, 3, 4. Go ahead and jot that down. I know that my graph is going to end up there. Okay, then I'm going to vertically reflect my red points. So vertically reflect means that everything is going to flip over the x-axis. So I'm going to reflect, they're going to go down. So I'm at negative 1/3, negative 1, and negative 3. It is a mirror image over the x-axis. Then I'm going to take all those points and move them right to, and then I'm going to, and then maybe I'll erase so I don't have so many out here. And then I'm going to move it up 4. So I'll end up, not quite, a little off. I'll end up here, here, and here. Not quite sure why I can't. Oh, I can. I just erased the points I wanted. Okay, I'll do it one more time. So we're here and here. There we go. Okay, one long curve going near the asymptote, arrows on both sides, and an equation y equals 4. Like I said, this is an R3. It doesn't get any harder than this. 3 transformations plus decay. This is our final problem together. So what I want you to do is to turn off the video, try it, and then you're going to test it against my final answer. Let's see if we get the same thing. I should mention as I was going through this, with a vertical reflection and horizontal reflection, it doesn't matter which one you do first, but you have to do them both first before you move it up 1. Okay, back to the work. Okay, how'd we do? I reflected vertically first and then the horizontal reflection. And then I moved it up 1, which means that my horizontal asymptote is at y equals 1. Okay, so make sure that you're able to tell the difference between a translation and a reflection. All that means is in the function, the plus or minus the number tells you if it's going right, left, up, or down. And the reflection is it going a horizontal reflection or a vertical reflection? Are you able to translate? That's what these are. Can you reflect over the x-axis versus the y-axis? And are you able to graph this very last one? Did a combination of translations and reflections. Okay, one slide left. So I have a worksheet for practice. This is the first time that the worksheet is due before the end of class for attendance. There were so few components today, and this is so important for me to give you feedback that given that our class is almost an hour and a half, that's plenty of time for you to do those 6 problems. So to get attendance today, you need to complete that worksheet and submit it. I'm excited to see what you do. Congratulations on finishing day 5. We have almost finished an entire chapter in e-learning. Talk to you soon. Bye.